The adsorption of methylene blue from the aqueous solution using calcium alginate and hydroxypropylcellulose-based hydrogels will be carried out in a batch adsorption experiment by examining the bed size of percent removal and adsorption capacity, and investigating the effect of experimental variables such as duration of contact time, pH, and initial concentration of methylene blue in the solution. All the experiments will be done in triplicates. The chemicals to be used are calcium chloride, hydroxypropylcellulose, sodium alginate, methylene blue, and distilled water. The methylene blue solution of specific concentration of 5 ppm and 10 ppm will be prepared by getting a 6.25 ml for 5 ppm and 12.5 ml in 10 ppm and diluting it into a 25 ml volumetric flask. This will be done by means of molarity. Calcium chloride solution with a concentration of 5% weight will be used as a bath during the extrusion of the adsorbent beads. To achieve this concentration, a 12.5 gram of calcium chloride will be weighed and crushed further. It will then be placed in a 500 ml beaker and will be dissolved with 250 ml distilled water using a magnetic stirrer. The ratio of 75-25 sodium alginate hydroxypropylcellulose will be dissolved using a 100 ml of distilled water and stirred using a magnetic stirrer at 300 rpm for 10 to 20 minutes, forming a colloidal solution. The colloidal solution will be extruded dropwise to the prepared calcium chloride, in which the colloidal solution will form solid beads immediately. The beads will be setting with the calcium chloride solution for 10 to 15 minutes to harden. Then the beads will be filtered from its calcium chloride solution and will be washed dry with distilled water. The size of the beads will be determined before and after adsorption process. The equation presented where dp bar is the average diameter of the beads, dp is the diameter of the individual beads, and n is the number of beads used for the experiment. Smaller beads offer large surface areas, thus higher adsorption. Since the contact time affects the removal of methylene blue form of solution, place a 0.1 grams into a 250 ml methylene blue solution. The concentration of methylene blue in solution will be recorded at 30, 60, 90, and 120 minutes. The amount of methylene blue in the solution after each contact time will be measured to determine the adsorption capacity of the hydrogel beads. The adsorption of adsorbent beads will be evaluated in terms of percent removal by this equation, where epsilon is the percent removal of the methylene blue, CO is the initial concentration of methylene blue, and C is the equilibrium concentration of methylene blue at given time. The equation of methylene blue remaining in the solution will be determined by the use of ultraviolet visible spectrophotometry. Adsorption capacity also obtained, and it is the amount of adsorbate that will be taken up by the adsorbent. The adsorption capacity is the equation shown where Q represents the quantity of methylene blue per unit mass of beads, CO is the initial concentration of methylene blue, C is the equilibrium concentration of methylene blue at time, M is the mass of the beads in grams, and V is the volume of the methylene blue dye solution in liters. The pH of the methylene blue solution will greatly affect the entire adsorption process, particularly the adsorption capacity. In each run, 25 ml methylene blue of a certain pH will be poured into a volumetric flask containing a 0.1 gram of centi-size adsorbent beads. In achieving the desired pH, droplets of 0.1 m HCl or NaOH will be added to the solution and will be measured by pH meter for 20 seconds. Adsorption will be highly dependent on initial concentrations of methylene blue solution. It is because at high concentrations the available sites of adsorption become fewer, making the percentage removal of methylene blue dependent on initial concentration. In each run, 25 ml of methylene blue solution of a certain initial concentration will be contained by a volumetric flask containing a 0.1 gram of the beads. Presented here are the table for the varying of initial concentration of methylene blue with the varying contact time of 30, 60, 90, and 120 minutes, and with the varying pH from 3, 5, 7, and 11. Their adsorption capacity and percent removal will be then obtained using the aforementioned equations.